Okay. So, good evening, friends. Assalamualaikum. Okay. So first let's discuss the homework. So I gave you some ST graphs. Okay, I have unnecessarily shown the minus part here. So first ST graph was this. Okay, second ST graph was this. So if we see the answers, so only like 2 students sent me through email, like 3 people. So I corrected and sent the corrected answers to them. So I identified some of the mistakes and most of them were correct. So I will discuss all the questions. I will tell you one of the important mistakes that everyone, I mean, 2 out of 3 people did. So now, so here you have to consider only 2 things about the gradient. Okay. So when converting this ST graph to VT graph, you know that the gradient of ST graph is the VT graph. Okay. So here, what happens to gradient? So first, if we see the angle, this is acute angle. So gradient is plus. Okay, gradient is plus, and with the time it is decreasing. Okay, what you see is it's decreasing, and here it becomes flat. So if it is flat, we call it parallel to the x-axis. Okay, so if it is parallel to the x-axis, at that point gradient is then gradient is
0.
0. Good. Gradient is 0. So gradient m is equal to 0 at this particular point. Okay, and then after that you have this obtuse angle. So obtuse angle means it is negative gradient, and here the obtuse angle is increasing. Yes, it comes like this. Sorry, obtuse angle is decreasing. Okay, it comes like this. Here 5, and then here decrease, right? Decreasing. So when obtuse angle decreases in negative values, the tan theta will increase. Okay, so the first part is positive decreasing, second part is negative increasing. If you draw the VT graph, the VT graph plus minus sides are important because you have graphs in the plus side and also in the minus side. Okay, so plus gradient decreasing up to 0 and then increasing in negative side. It will be like this. Okay, so this is how you draw. For this one, if you see, it is obtuse angle, so negative, and it is decreasing. And here it becomes what? Sorry, angle is increasing, and here it becomes 0. Okay, so from a higher value, it becomes 0. So gradient in negative decreases, having 0 here, and then it is acute angle. Angle is increasing, right? From 0 to it is increasing gradually. So in negative, decreasing and coming to 0. Okay, in minus side, decreasing and coming to 0, and then increasing in positive side. Okay, so this is how you do. Okay, and the other ones are like almost easy ones. Very easy, like you do it very easily. So I will discuss anyway. So the other one is the ST graph is like this. ST graph is like this. So most of the people confused it with, like, you know, coming into the positive and negative sides of the ST graph. Okay, so here you don't see the sign of S. Okay, did we see the sign of S anywhere? Did we consider it anywhere? No. We only considered the gradient. So we go for the angle. So angle is the same and it's obtuse. So negative gradient constant. Okay, so in the VT graph, negative side constant. That is the correct answer. And then the other one is like this. Okay, so here if you see the angle, it is acute angle. No, acute angle. So the gradient is positive and it is a straight line. So in the positive side, it will be constant. Okay, like this. Positive side. positive side. So this is negative side, this is positive side. Okay. So don't confuse the plus minus of S. You should see only the angle. And then fifth one, many people drew the question wrongly. Okay. So the actual question was, if you remember, the actual question was like this. Do you remember ST? It was like this. We gave it like this. Okay. So up to this curve, and then it is a straight line. Did you see a break here? Break in sense coming like this and going like this. These two have difference, right? Here it comes like this, and immediately it goes like this. So here you see a break. The graph breaks. So here you see some angle, and immediately that angle decreases. Okay. So this meaning is completely different from the meaning of this graph. Here the gradient gradually increases. Okay, the theta increases. And at this point, it starts to remain stationary. So it increases up to here, and then that value remains constant. But if you draw like this, you break here. So you bring it to some value up to this point, and after that you reduce the value for that particular segment. For this part, the straight line part, you are reducing the gradient. Okay, so don't do that. So don't show a break here. So if there is a break, the graph will be different. So without break, the graph will be like increasing in positive and then remaining constant. Okay, so this is the VT graph for this. And then another question I gave was this one. This one, right? This one. It is not a sine graph, okay? If it is a sine graph, that will tell that will have a different meaning. That is simple harmonic motion. This is not simple harmonic motion. Okay, this is some thing that we talking the linear motion. Okay, remember it like that. So this is a linear motion. So you do the conversion like you do for the linear motion. So don't do the graph conversion like you do in the simple harmonic motion. Then the answers will be different. Okay. So now I am going to create a question from this particular graph, because this graph is very important to understand. Okay, many confusing MCQs can be prepared from this. Okay, so let's see. So this is how this graph looks like. Okay, draw it in your notebook. Draw it in your notebook. Draw it in your notebook. Okay. So now I'm going to put some kind instances, okay, by the time values by T1, T2, T3, T4. And I'm going to give you a theory question for you. Okay. So let's see how many of you solve it correctly. So here, the question is identify the instances in which the direction of A displacement B velocity, all are factors, so they will have a direction. Acceleration. So you have to identify the instances where the directions of displacement, B velocity, C acceleration change. Okay, I will give you 1 minute. Identify very quickly. I think students, I don't have proper network, no? Like due to the power cut. Okay, so time up. So here you have to identify the instances where the directions of these three parameters change. Okay, so if you consider the displacement or velocity or acceleration, anything, so change of direction means, okay, the meaning is going from positive to negative or negative to positive. So that is called a change in direction. Am I correct? Going from positive to negative or negative to positive is called the change of direction. Okay, so here, can you identify the instance where the displacement changes its direction because it is displacement time graph? So we can easily see the displacement. You don't have to like critically think to interpret the displacement because it is itself a displacement time graph. So we can just see and comment where the displacement changes its direction. Can you tell me the instance where displacement changes its direction? Do you see an instance where it comes from positive to negative, negative to positive? Yes. Yeah. At this point T2, okay, at this point T2, it goes from positive to negative. Okay, so this area is in the positive side and this part is in the negative side. So at this T2, the displacement changes its direction. So it is only in one instance, T2. What about velocity? So to see velocity, let's draw the velocity time graph for this ST graph. Okay, so if we draw VT graph for this, okay, VT graph for this. So now tell me, how do you draw? So this is the answer for our question also. Okay, so here the angle is decreasing and coming to zero. So the positive acute angle decreasing and coming to zero. So it means that positive gradient is decreasing. Am I correct? Positive gradient is decreasing. So how do we draw it here? Positive gradient decreasing and hitting zero at this point T1. And then after that, you see the obtuse angle. Okay. And it becomes T2 at this, I mean, time is T2, but you don't see that flattening, no? The angle is increased, sorry, decreasing in negative side. In negative side, if the angle is decreasing, it means that the gradient is increasing. Okay, so the negative velocity is increasing. Negative velocity will increase and it will attain some value. Okay, so at T2 it will have some value. And after that also you see this obtuse angle. But at this point the angle becomes 180. 180 means that is also zero. Tan 180 is zero. Yesterday, no, day before yesterday, I explained you that in the first class. Okay, and 180 is also zero. So here the negative gradient should decrease and become zero. Okay, so his negative gradient will decrease and become zero. And this is T3. And after that, what is this? What is this gradient? Can you tell me the gradient sign and variation? Tell me, Akil, can you tell me what is the sign, plus or minus? So can you repeat the question? So here you should tell me the sign of the gradient, whether it is positive or negative, and it is increasing or decreasing, the variation also. This is acute angle, right? So the sign should be
Positive.
Positive. And the angle is increasing. So if the acute angle is increasing, the variation is increasing, right? Okay. So positive velocity, the gradient is the velocity. So if we say gradient, that is actually velocity. So the positive gradient is increasing. So it means that positive velocity increasing. So if you understand if you understand this like this, you will never leave a mistake. That is why we have concepts. Okay, so we don't remember the, you know, we don't remember the different examples. We remember the concept, and from that we understand the examples. Okay, we apply it everywhere. Okay, I think I became over emotional. Okay, there are chats. You people are very good in using the chat box, right? Yeah. 5 messages. Wow. Everybody is answering the chat. The thing is, I don't frequently check the chat. Okay, so let's come to the question. So here the gradient in positive, it increases. So if you understand that concept, then you will never leave mistake. Okay, so it's, you should apply it everywhere, and then you should understand it. So here now VT graph is ready for you. This is T4. So now you have to identify where the direction of the velocity changes. So let's look at the instances where it goes from positive to negative or negative to positive. That's the thing. No? So if you see at T1, it's from positive to negative. So here it changes the direction. Here T3, it is negative to positive. So there also it changes the direction. So at T1 and T3, okay, the velocity changes direction. And then acceleration. So for that, what should you do? What should you do? The easier way is to draw acceleration time graph and see. So let's draw acceleration time graph here. AT graph. So if you see, the gradient of VT graph is acceleration. So you should go for the gradient of VT graph. So here, this is what kind of angle is this? You see? To see the gradient, we go for the tan theta. Okay, so this theta, the angle is obtuse. So it is negative gradient. Okay, negative gradient. And this is a straight line. So the gradient is constant. So negative gradient, constant. And then in this side, if you see the gradient, we should always draw the horizontal line and see the angle this side. So if this is a graph, you don't go for the angle this side. Okay, so always the angle in the positive side. So this is the positive x side. No, so positive side, you go for the angle. You also you go for this angle, not the angle in this side. So this positive gradient, so it means that it's positive. Acute angle, so it's positive. Sorry, acute angle, it means positive, and it's a straight line. It is constant. So the positive acceleration constant. Okay. So where the cell, so if you, the time, this is T1, this is T2, this is T3, and this is T4. Okay, T4. So at T2 only, you have change of direction. It goes from negative to positive. Okay, it goes from negative to positive. Okay. Okay. Understood. So now we are going to do other questions. Okay. So there are other graphs. Okay, if you had a doubt, just ask me. Using the concept, you can draw. Okay, and one more. So for this answer is T3, T2. One more question I should discuss because you left this week. So for this ST graph, what is the VT graph? What is the VT graph here? You have enough time, you can try. Okay. VT. So here, if you see, so first you go for the angle. So here it is, what angle is this? Acute angle,
Acute
decrease.
angle.
decreasing, right? And here it becomes 0. So this part, this small part of this graph is actually parallel to the x-axis. So it doesn't have any angle. Okay, if two lines are like this, they don't have any angle between them. So here the angle is 0. Okay, so you should explain it like this. So gradient is positive because acute angle, and it's gradually decreasing and becoming 0. So positive velocity decreasing and becoming 0. So positive velocity decreasing and becoming 0. And it remains 0 for some time. So you draw like this. And then after this, what is this? Again, the acute angle. So positive increasing, right? So then it will be like this. Okay. So if you use the concept is everything and you will never leave any mistake. Okay. So that's why we study the concept. So don't remember each and every example. Just remember the concept and apply it everywhere. Then you will understand. Because it is 1 mark. Okay. 1 mark. So if you want to assure 1 mark in the final paper, you just practice it and go. Okay, so let's move on to the questions from the Pesuru book. So with today we are finishing the linear motion. So next week I will be discussing about the center of gravity. Okay, center of gravity, resultant force, okay, and equilibrium. Center of gravity, resultant force, and equilibrium. Okay, so you have to revise. You have to go through. And if you are coming, you have to go through the theory, relevant theory, and you should come with a lot of doubts. Okay, you can ask. So that's why the class is for. You have to ask the doubts. You can ask for WhatsApp. You can ask for email, anything, and whichever the question I give you, you do it and send. If you just send the photo also through email, it's okay. I ask you to send through email because I have to correct your answers. Then only I find mistakes. So today you learned from one mistake, you know? Yeah, you learn from one mistake. Like that, you will learn from mistakes. Okay. So let's move on. So what about the fourth question from Pesurubu? Fourth question. So I will go one by one. So fourth question, quickly drawing the diagram. So this is T1, this is T2, this is T3. So this is a VT graph. Okay, so you should interpret. You should be able to interpret a VT graph to answer this question. Okay, so let's read the question. The figure shows velocity time graph for a particle which starts from rest. So you can see the velocity is 0 at t is equal to 0. At time is equal to 0, it is 0. So it starts from rest and moves along x direction according to this graph. So x direction means it is a linear direction. Okay, x direction, along x direction. The particle comes to rest only at time t is equal to t3. So for this one, if you have good eyesight, you will answer it correctly. Okay, so what do you see here? Rest means velocity 0. Okay, so what are the instances where the velocity becomes 0? No theory to apply, no? So just T2, it becomes 0. T3 also, it becomes 0.
T equals to 2.
T.
T equals
Yeah.
to 3.
Yeah, T2 and T3. Okay, so those are the instances. So only at time T3 is wrong. Okay, so no need to interpret this graph, just looking at it and answering. Okay, so B, the particle returns to its original position. So position is related to the displacement. So you start the motion from a point, okay, you travel everywhere, and the displacement will decide whether you come to the initial position. So if you come to the same point, then your displacement is 0. Okay, you go everywhere and you finally come here, and then there will be a displacement. So its position is not the initial position. The initial position means the displacement 0. So you have to see whether the displacement is 0 here. So how do you see the displacement in a VT graph? So you know, area of VT graph will give you the displacement. Another thing is gradient will of VT graph will give you acceleration. So these two theories you should know. So you should see whether the resultant displacement is zero here. Okay. So here, if you see the displacement, so this area will give the displacement occurred from T0 to T2. So it is in positive direction. Okay, so there will be a positive displacement. And here it is velocity is negative. It means that the object was traveling in one direction and it is returning from the particular destination it went for. Okay, I mean it was initially traveling in this direction, and then the negative means it is traveling back towards this initial point. Okay, so this negative area means negative displacement. So displacement is decreasing in this part. So in positive direction there is a displacement and it is returning back. So in the negative direction also there is displacement. So do you think the resultant is zero? Do you think the resultant is zero? Well, no, because here obviously the positive is greater than the negative. Okay, so it is like this. From this point, for example, it has traveled up to here and it was coming in the opposite direction. Okay, from here it was coming from in the opposite direction and it is stopped somewhere here. Okay, so the displacement traveled in the positive direction is greater than the displacement traveled in negative direction. So it is not at the initial point, there is a displacement. Okay, so that statement is wrong. The first statement is wrong, second statement is also wrong. Okay, the third statement is the particle accelerates only during time interval 0 to t1. Particle accelerates only in the time interval 0 to t1. What do you think? Particle accelerates. So you convert it to acceleration. Yeah, what?
It accelerates even in T2 to T3.
T2 to T3.
No, so that
Here
half
to here.
triangle.
Yeah, that half of it, no? So in between these two. So you're telling that from here to here also it accelerates. So actually
Yes,
the
sir.
word acceleration means, the word acceleration means velocity increasing, right? Velocity increasing. So in this part of the graph until T1, 0 to T1, the velocity is increasing, right? Up to this point, the velocity is increasing. And then up to from T1 to T2, the velocity is decreasing. So that is deceleration. So 0 to T1, acceleration, T1 to T2, deceleration. And then from here, it becomes 0 and starts increasing its velocity in the minus direction. So it is also actually acceleration. If you say that this is T dash, for example, from T2 to T dash duration, it is accelerating. The velocity is increasing. And from T dash to T3, the velocity is decreasing. So it is again deceleration. Okay, very good. So what you said is exactly correct. So particle accelerates only during the time 0 to T1 is wrong. It is accelerating in this duration also. Okay, so the correct answer would be, so A is wrong. Okay, B is wrong. Okay, C is also wrong. So all three statements are incorrect, right? So in that particular year, so you can see there is no correct answer. Okay, 1993. So they gave, I think, open for that. Okay, so in some past papers they have corrected it. The last statement in some past papers is all are incorrect. So if you correct it, you can give answer, fifth answer. Okay, so then fifth answer. Sorry, fifth question. Fifth question. So it's a good question. An object dropped from the height h bounces back from the floor to the height h by 2. Which of the following VT graphs represents the motion of the object? So you drop object from here, so it bounces. So compared to a soft ball, for example, okay, any small ball, you're putting it and it comes back. Okay, so sometimes, I mean, most of the time, it doesn't comes back to your hand, no, always. It stops at a smaller height and it goes back. So they say that you put it from H and it bounces back to the height, to a height h by 2. Okay, so velocity time graph. Can you try this? So what should happen to the velocity if you drop from here? The velocity should increase because it is under the influence of gravity. There will be gravitational acceleration. So initially it will accelerate, so it will reach a velocity. When it bounces back, okay, it bounces back, there is a velocity, and that velocity only brings it up to h by 2. Okay, so as you have studied all the theory, can you tell me what kind of a collision is this? What kind of a collision does it perform with the flow? There are types of
Inelastic.
collision. Inelastic. Very good. So there is loss of kinetic energy. Okay, loss of kinetic energy. So that is called, there is no loss of energy. Energy is conserved universally. Loss of kinetic energy, or you can say mechanical energy. So loss of mechanical energy. So the height it hits is different from the height it bounces back. Sorry, the velocity it hits with is different from the velocity it returns back. Okay, so always the returning velocity is smaller than the hitting velocity. Okay, so that it will attain only a smaller height when compared to the original position. Okay, so it should start from less velocity. Okay, and then it should come to rest again. So that occurs in negative direction. If this is in positive direction, this is negative, no. So negative side, you draw it like this. And another important thing is, in here, what was the acceleration? What was the accelerating factor for this motion? So here, if you draw it, the mg is the force, okay? So mg is equal to ma. If you use F is equal to ma for this motion. So mm cancelled out. So A is equal to G, right? So here the A was equal to G. Here also, if you use it, A will be equal to G because for the object, the mg is the only resultant force. So for this part and this part, for those two motions, the acceleration is same. So that means the gradient of these two segments should be same. Okay, the gradient should be same. So these two should be parallel. So that should be considered when selecting the correct answer. I will repeat it again. These two gradients will give acceleration. Okay, these two gradients will give acceleration. So the accelerations are equal. So these two gradients should be equal. So these two angles should be equal. So these two should be parallel. These two should be parallel. So see that also in the answers. Okay, if they don't show it like parallel, you can't select an answer. And then here this area will give you the displacement. So that is h. This area should give you the displacement, which is h by 2, because it is returning only up to h by 2. No, it's not going up to h. Okay, so lesser displacement. So the area of this part should be greater than the area of this part. So that also should be considered. So considering all these, what is the best answer that you can get? I think it's the first one. No, it's the first one. The first one is okay. Second one, that is for elastic collision. Okay, Third one, that is not possible. That's completely wrong. Fourth one, you can see the gradient of this part is lesser than the gradient of this part. And the fourth one also, the gradient differs. Okay, so we can't take it. So sixth question, I don't have to do, I think. Okay, a seventh one. So acceleration is represented by this shape. That thing you know. Okay, acceleration is represented by this shape. Okay, so I will do the ninth one. Okay, ninth one. Which of the following curves correctly represents the corresponding velocity time curve for the displacement time curve shown in the figure? Okay, so try the answers if you haven't done this. I will keep model paper exams also, okay, in between. So you can't, like, for these, if you try again and again, you will remember the answer. So when you try model papers, you can't remember the answer. So you have to do so. But when it comes to the past papers, even like, for me, according to me, even remembering and practicing again is also okay. At one point, you will, like, become an expert in explaining past paper MCQs. Okay, so it's not exactly the one they have given, but I will draw it. Similar to it, okay. So as you all know, okay, I will draw the PT graph. So this is an easier one because there are no curved lines, only straight lines. So it's always a constant gradient. The velocity is constant. So in this part, in this part, in this part, in this part, what about the velocity? Which so in this part, as you see, it is acute angle, right? Positive gradient, constant. So you draw like this. In this part, what's that? This part, it is negative, right? Negative. And it is constant from here to here. What will you say about the magnitude of this one and this one in the actual question? Not this one. This is a little bit different from the actual one. In the actual one, you can see the slope of this graph is similar to the slope of this graph. I mean, that particular portion of the graph. The slope of this part is equal to the slope of this part. So these two have same gradients. Okay, if you take this one, it looks like an isosceles triangle. So these two should have same gradient, right? So this one will have same magnitude as this one. Only the difference is direction. Direction is opposite here. So you draw it like this. And here, as you see, it is parallel to the x-axis. So the gradient is 0. So you draw 0 here. You just darken the graph here. And then here, the angle is acute. Okay, angle is acute. And you can see the slope is like a little like this, no? Not as inclined as this. So I think the gradient is a little bit small in this part. So you should draw it like this, a little bit smaller one when compared to this one. The slope is like very, small. Okay, so the correct answer would be second one. Sorry, fourth one. Okay, fourth one. Okay, 10th one, you can do it easily. And then I will directly go to the 12th one. Okay, 12th one. So 12th one, I'm going to discuss some theory also because I didn't teach you the relative motion. Okay, so we shall read it first. 12. When two objects A and B move with uniform speeds towards each other, along a straight line, they get 5 meters closer to each other every second. Okay, so every second they get close to each other by 5 meters. Okay, and then if they move in the same direction along a straight line with the original speeds, they get 1 meter closer to each other every second. The speeds of A and B respectively, what are their velocities? That's the question. So the concept that you can apply here is, one is you can try each and every answer and see whether it sounds correct. Okay, so when they move from each other for every second, if they, like, I mean, they're moving towards each other, no? So if they get 5 meter closer to each other, so it means that the both velocities should bring 5 meter displacement per second. Okay, so when you add those two velocities, that should give you 5. Okay, so that is the logic. So among the answers, only I think the third answer is possible. Okay, so with third answer is 3 meter second minus 1 and 2 meter second minus 1. So if you move for 1 second with 2 meter second minus 1, you move 2 meters. And with 3, you move 3 meters. So with those two, if you move towards each other, you will get 5 meters. You will travel 5 meters towards each other. Okay, so this is the logical one. But you can apply a theory also here. That is called relative velocity. Okay, so let's discuss that. What is relative velocity? For relative vector, any vector you can talk about relative. So there is a general equation for this. VAB. It means that velocity of A relative to B. Velocity of A relative to B is equal to VA minus VB. This is the equation. Velocity of A minus velocity of B. So these two velocities are relative to Earth. All the motions happen in Earth, so that we talk about the motion relative to Earth in these instances. So A, comma B, comma E. So we put it like this. So this is the common equation. Okay. So you can use this equation and also find this out. Okay. So shall we try to do it using that? Okay. So when they are moving towards each other, so let's say object A is here and object B is here. So they are moving towards each other. So it has velocity VA, it has velocity VB. And they are moving in the same direction. So here the relative velocity. So I'm going to see velocity of A relative to B. Okay. So VAB is equal to, as you all know, VA minus VB. Okay. And if you see, the directions are different. This is in this direction, this is in this direction. So you can't add two vectors with opposite directions. So you have to convert one of them to the same direction as the other. Okay. So I'm going to convert this to the other side. I'm going to convert VB this to VB this. So to make it technically correct, I have to put a minus. So VB in this direction is equal to minus VB in this direction. Okay, so that's how you interpret. So if you substitute this, sorry, VA minus VB in this direction to this, minus into minus will become plus, so plus VB in this direction. Okay, so this is how you get the equation. Okay, direction is not very important here because I have taken an example diagram. Okay, what about this? So V A comma B is equal to V A minus VB. So this velocity is actually 5 ms minus 1. As they say, in 1 second, they get 5 meter closer to each other, means they have this relative velocity of 5. And here this velocity is 1 because they get only 1 meter closer to each other. So it means 1 m is minus 1. So you can see that the two values, when they are subtracted, they produce 1. When they are added, they produce 5. Okay, so it should be 3 and 2. It should be 3 and 2. Okay, otherwise you can, like, you have two unknown things and you have two equations. You can solve this also, but that is not the proper way. It's time consuming. So the next question, 13th one. Okay, so 13th one, they say displacement of a particle S is measured along the x-axis with time t is shown in the figure. The magnitude of the velocity of particle is largest when it travels from. So how do you see the velocity, magnitude of the velocity? Can someone give me an impressive answer? An impressive answer. We should go for what in these kinds of questions? Velocity is the question. You should go for what? You can answer anything, okay? I was talking about something called gradient, gradient. That is more technical, but I was talking about another thing, that is slope. So something is very, very inclined, it has a greater angle with the horizontal. That means that will have a greater gradient. Am I correct? Okay, if it is more steep, then you can say the velocity is high, the gradient is high. So if you see this, that there are, it is drawn according to a calibrated, x-axis and y-axis are calibrated equally. So you can calculate also, but that is not impressive. That method, if you do that, I will not be impressed. But if you just look at it and answer using the slope, then okay, it is a shortcut. So it is a very good answer. It will be a very good method to go. Okay, so where do you see a higher slope? Where do you see a higher slope? Answer me.
B to C.
Yeah. B to C. Excellent. Yeah. So that is how you have to go. And 14th one, similar to the previous one. And 15th one, we have already discussed that in our practice questions. 16th one discussed. 17th one. It is a very interesting one. Okay. So they are asking 17th one. See, in which of the velocity time graphs shown below would the average velocity over the entire period between t1 and t2 be equal to the average of the two velocities at the ends A and B of the interval? Okay, so it may be a little bit confusing with the the sentences. So if you see this carefully, they are telling the average velocity should be equal to the direct average of VA and VB. Okay, so they are asking that a particular motion will have an average velocity. No, it will have an average velocity. The average velocity means average velocity. Velocity means the total displacement divided by total time. So that is the average. That is the average. So that average should be calculated by calculating the total displacement and dividing it by time. So here the different graphs, for example, if you take first graph, it is like this. And this is A and this is B. This is BT graph. Okay. So it will have a displacement which is given by area. It is given by its area under the graph. The area under the graph. So this one is the displacement. So this displacement divided by this time will give you the average velocity. And the second average of the two velocities at the ends A and B means, read that carefully, the last part. average of the two velocities at the ends A and B of the interval. Okay, so that average is VA plus VB divided by 2. So actual average velocity should be equal to VA plus VB divided by 2 in the answer. So how are you going to do this? How to do this? Well, you have mathematical equations like finding the area of this curve and proving it to be like that. Can you see some familiar ones? In the fifth one, we see a familiar one. Okay, so that's why this question is easy. If we don't have a familiar one, we cannot answer. Okay, we cannot answer if you don't see a familiar one very easily. So that they have given a familiar one, which is the correct answer also eventually. So see the fifth one. Okay, see the fifth one. Fifth one is easily calculatable. Okay, so the actual average velocity of this motion is, sorry, AB. Actual average velocity of this motion is total displacement over total time. No. So what is total displacement? This area. So can you tell me the equation for total area of this? The time is t. What is this 2D diagram? What is this 2D shape called? Trapezium. There are, yeah, trapezium. So tell me the equation for area of trapezium. Half.
Half into x plus y into height, perpendicular
Yeah,
height.
sum. Yeah, perpendicular height. X plus y means sum of the parallel sides. So this is VA and this is VB. VA plus VB. Okay. Divided by 2 is already there. Sorry. So half is already there. And multiplied by the perpendicular height. And here below that you have to put total time to calculate the average velocity. So these two times are cancelled out. So it's equal to VA plus VB divided by 2. So fortunately, you have that familiar guy, and that guy gives you what you expected. Okay, so the fifth answer is the answer. So others are not easily calculatable. Okay, so those are not the correct answers actually. Okay, so when they give like this, you have to be like, you know, a little bit cautious about handling the question. You can't go for the other, you can't like do sums for others. But if you go for the fifth one, which is familiar one, that is the right way. Okay, so then 18th one is okay. Okay, 19th one. So 19th one is very important. So in your teacher's guide also, they have told us, okay, teachers, to teach you all to graphically represent the direction of motion of an object. Okay, so here you see a person A standing on a trolley with a constant speed V on a straight horizontal track drops an object as shown in the figure. B is not observer. B is not observer standing on the ground. If the air B is B is an observer standing on the ground. If the air resistance is negligible, the paths of the objects as observed by A and B are represented by. Okay, there are some mistakes. No, in this, is it actually not? B is an observer. Okay, this is stationary. So what will B observe and what will A observe? That is the question. Okay. So here the path of the motion is the question. Path of the motion. So how do you decide the path of the motion? If an object is having a velocity in this direction, V, and this is the path of the motion. Okay. If an object is having acceleration in this direction, this is the path of the motion. You don't have to like draw the arrow, but it is better to draw the arrow. What if an object having a uniform velocity in this direction and also a uniform velocity in this direction? Can you draw it in your exercise book? Can you draw the path for this in your exercise book? Path. Path. I only asked for the path. Okay. Not the resultant and all. This is also a uniform velocity. It has two components for the velocity actually. One horizontal component, the other one is vertical component. Both are there for that object. Uniform velocities. What's the path? It will be like this. Okay. If this is higher than this, it will be more towards this side, like still more towards this side. If it is higher, it's more towards that side, but still a oblique line. Okay. Between the horizontal and vertical, but a straight line more towards the higher velocity. You have to note it down. The path will be more towards the higher velocity. What about this one? An object having path of an object having a uniform velocity in this side and an acceleration in this side. What will be the path? What will be the path? I am giving you knowledge to do the questions, okay? So that is the only useful thing. If you just do the questions, you can't, okay? So I give you the theory behind it. So that's why we are talking about the theory. So here the acceleration will draw the object towards it. Okay, that component of velocity is constantly increasing, right? So the path will be moving towards A. So it will be like this. The path is like this. What about this one? A deceleration and B. It's a deceleration. So deceleration, velocity is decreasing. So it will move more towards the velocity side. Okay. Deceleration in this side and acceleration this side. What's the answer? Acceleration is decreasing. So it will move more towards the velocity side. Okay. So that's how you decide the path. Okay, note it down. So now for B in A, what are the paths? So A is like this. So he is dropping the ball. So A is in a stationary platform. B is in a moving platform or frame, we can say. So these two, relevant to these two frames, there will be different velocities and acceleration for this. Okay. So according to A, you know, obviously there will be an acceleration in this side, right? Because gravity is always pulling this downwards, so that acceleration is there. Okay. Is there anything else? So this object was traveling, yeah, with the trolley. So this trolley is having a velocity. So all the objects in that trolley will have the velocity of the trolley. So this ball will also have a velocity in this direction. So this stationary person in a stationary frame will see this velocity because he doesn't have such a velocity, but he has ball has the velocity. So the path should be determined by uh, velocity in this direction and an acceleration in this direction. Okay, the path should be determined by two things. So what is the path? Like this. Okay, like this. For A, that is the path. Sorry, B, that is the path. B is the stationary one. What about A? What are the things that A would see? So I have written it the other way. No, this is B, this is A. Sorry for the confusion. In the question, it's other way. So I just change it. It's B, it is A. Okay. So what about A? What do you think about A? Tell me, Alia Ramzi. What are the things that A would see?
Acceleration downwards.
Yeah. Will A see any velocity?
No, because trolley is also in the same velocity towards the the horizontal.
Yes. Good. So this A is having a velocity V. Okay. So you are traveling in a bus. The bus driver is traveling with the velocity 50 km/1. You're also traveling with 50 km/1. Relative to you, the driver is not moving. There is a fixed number of seats between you and driver. No, it's not moving. Okay, it's not moving. The distance is same. So it's not moving. So you don't feel the velocity. You don't see the velocity. Okay. So A will not see this velocity component of this ball because A is also having the velocity. So that's how the relative velocity works. So velocity of velocity of ball relative to A is equal to velocity of ball minus velocity of A. So if you see horizontally, B is also having the velocity in this direction. A is also having velocity in this direction. So that is 0. So this is more mathematical. But if we talk like this, both of them are moving in the same direction, same velocity, they won't see the motion. So he will see only this acceleration. So what's the path? This is the path. So A will see vertical downwards, B will see this path like this. So the correct answer would be the second answer, right? Second answer. So you try what is the path of the ball for A and B. If A throws it vertically upwards, you think about it. Okay, you think about it. You can send me the answer through WhatsApp maybe. It's just one photo, so you don't have to send through email. So you just send me through WhatsApp. Vertically upwards. Okay. Okay. So then 20th one, you can draw like 20th one is a projectile. Okay, projectile. Okay, we shall discuss that. We have enough time now. We have enough time. Okay, a stone thrown, 20th one. Okay, a stone thrown at a certain angle with horizontal in the direction as shown by the arrow. If RSS is ignored, which of the following velocity time graphs best represent the variation of Vx with Vy? Sorry, Vx with t and Vy with t. Vy means the horizontal, so vertical. Vx means the horizontal velocity. Okay, so let's try to understand this projectile motion. So what is a projectile motion? A projectile motion is a motion under gravity when the object is having a horizontal velocity. Okay, so it will have a horizontal velocity and also it will be under gravity. So there will be a vertical motion which is under gravity and a horizontal velocity also. So one example is to kick a ball from here, like a football is kicking, for example. So he will give a velocity in this direction. So that will have a horizontal component and a vertical component. So it will have vertical motion and also horizontal motion. So the mixture of that motion will produce a resultant motion like this. A resultant motion like this. Okay, a resultant motion like this. So here this is the velocity v, and if this angle is theta, you say the horizontal velocity is v cos theta, the vertical velocity is v sin theta. Okay, this is the vx and this is vy. Okay, so you know vx, or the horizontal velocity, is not under any force. If you ignore the air resistance, there is no other force. Okay, so if you draw a free body diagram showing the forces acting on this ball, what is the force acting on the ball? Weight, only weight. So the force is perpendicular, sorry, force is vertical, which is perpendicular to the horizontal direction. So perpendicular forces will not have any influence on a motion. Okay, you are moving horizontally, the weight will not influence you. Okay, so this will be under no force. So that means that if there is no force, a moving object will move in uniform velocity, right? It's what it does in first law. So the Vx with time is a constant. The Vy, okay, the vertical component will be under the gravity. Okay, so it will have, when it moves upwards, it will have a downward acceleration or upward deceleration, minus g. Okay, downwards acceleration or upwards deceleration, both are correct. When it comes downwards acceleration, we don't call it upward deceleration. Okay, that's irrelevant. Okay, so we call it downwards acceleration, and this is upward deceleration. Okay, so you know it will go to rest here and then it will return back. So like you throw something and it is returning back. So it will be like this. Okay, so Vy is a vertical motion under gravity. Okay, so the correct answer would be the 1 and 3 for Vx and Vy. Okay. #21st. If you have any doubts, just let me know. Okay, 21st is easier one, so I am not doing that. We shall go to the 26th one. Okay, 26th. Oh, not 26th, sorry. 25th. 25th. So they are a question in a different format. Okay. Photographs of an object that starts falling freely from rest at t is equal to 0 are taken by a camera. First at t is equal to 0 and thereafter at the end of each second. Which of the following diagram correctly indicates the location of the object at the end of each second? Vertical axis of the diagrams represent the distance traveled by the object. Okay. So this is a question for you. Actually, it is taught as experiments, okay, in other syllabuses. We don't have this syllabus, but in the other syllabuses, if you see like Cambridge ones and all, they have specific practicals. That's a computerized practicals. Okay, we don't still have a computerized practical in our syllabus. We are so backwards. The one and only computerized practical that came was 2015 first structure. That is not that computerized also. Okay, so we are studying, actually we are analyzing a practical taught in other syllabuses. So what about pictures at each seconds? So it's about positions, right? So position means displacement. So you should see the displacement after each second. That's it. So it start from 0. Okay. So everywhere you see 0. Okay, so I mean 0 position everywhere, it's same. You can't exclude any answer using that. And then at first second, what about the position? So let's use vertically downwards. S is S is equal to ut plus half at square. As it is from rest, ut is 0, right? So S is equal to half. A is 10, but gravitational acceleration. T squared is 1 square for the first second. So this is 5 meters. So third answer is excluded. Okay, other answers are there. So then for the second, okay, for the T is equal to 2, if you use S is equal to ut plus half at square. The ut is always 0. From the start we are looking, okay, half A is 10, T is 2 square. So it is 5 and it is 20. Okay, the total displacement is 20 from 0. So the 20 is correctly shown only in the fourth answer. Okay, other answers are wrong. So fourth answer is the correct answer. So it's a simple question, a different format. Okay, using the cameras and all. Just they are just trying to complicate the question and then fail actually. Okay. Okay, then 26th one. The variation of velocity with time t of a particle is shown in the figure. The corresponding displacement time graph is best represented by which one? So here you have to convert the velocity time graph into displacement time graph. Okay, displacement time graph. So I'm going to draw it. You should all have all the explanations written. Okay, that is my humble request. Okay, otherwise no point. I am telling from my experience and the experience of many other children. I taught this explanation writing method to 23 batch. Okay, so that's the first batch I started to motivate it. So now they are at a different level. Actually, some of the students, I have never seen students performing like that. Okay, they are doing very well because they go and read Rosas's books. They ask me, they read some books and they find like proper explanations for each question. You don't have to write elaboration like Rosa sir. You should just have some of the logics written. Okay, some of the logics. Like I did for the second question when I explained you, I told some logics, no? So like that, you have to write some logics. So this is the time. Okay, this is the time to start revision. And the 23 batch is doing from 1979. We use J. Kumar's past paper. So that has from 1979. So they are like studying more questions than we study now. So it's more easier for you if you, so you are going to write experience for less number of questions. Okay, so you should do it. If 23 batch can do it, why can't the exam batch work hard this much? Why can't you people work hard? I will tell you how to study for the exams after some time. Okay, so I have to do a separate session. You have to start now. Whenever I tell these students, say, oh, why didn't you tell me like way back when I started the year, like 2022 August exam, no? You should know these things by January. Otherwise, you can't implement. So I have to tell it, okay, very early. So start preparing for the exam. It's too late, like if you haven't started it. Start today. I will tell you how to make a timetable. It's like this. Okay, students. So initially the velocity is positive. What is happening to the velocity? Positive direction. The velocity is increasing. Okay.
Increase.
Yes. So up to this, the velocity is increasing. They have given beautiful the lines. Okay, so that lines are very helpful when it comes to these questions. So within that, you can observe each segment by segment. You can discuss. So for this particular segment, the velocity is increasing. So what should happen to the gradient of displacement graph? Here, the positive gradient should increase. Here, the positive velocity is increasing. So here, the positive gradient should increase. So you draw like this. Initially, it's 0 now, so I draw it flat here and then increase the angle. And then here, after attaining this velocity, after attaining this gradient, so I'm using two languages. I will say velocity here and I will say gradient here. So those two terms, don't confuse, they are same, exactly the same. So after reaching this velocity, it's traveling with the same velocity sometimes. So after reaching this gradient, it will be traveling for the same gradient. Okay, so don't break it here. Don't draw it like this. Okay, so if you draw, that is wrong. See that? Did they have they drawn like that anywhere? No. It goes like this. And then velocity decreases and becomes 0. Okay. Positive side, positive velocity decreases and becomes 0. So positive gradient should decrease and become 0 in the ST graph. So positive comes in like that, it becomes 0 like this. Okay, it is flattened little by little, and here it is completely flat. After that, you see a negative side. So negative side for displacement means negative gradient. Obtuse angle. Okay, obtuse angle is drawn like this. So this is obtuse. Okay, and then this is again what is happening? Decreasing, right? Decreasing. The velocity negative side is decreasing. So the gradient in negative side should decrease and it becomes 0 here. So you decrease it like this. Okay. Got it? So you finish the graph here. Okay. Some students are sad. Okay, because this graph stops here. So if they give some answer like this, they will mark it. Okay, because they feel something wrong with this. It's actually correct. Okay. So that is just what our mind thinks. Okay, sometimes if it is like hanging here, you feel like it's the wrong answer, not like that. Use the concept. So here this means the positive displacement, and here it means the negative displacement. So obviously the negative displacement is less than the positive displacement. So it will not return to the original position. It went like this far, and then it comes only this far. So there is a difference between the original position, I mean displacement between the original position and the final position. So there is some displacement left. It is not 0. Okay, so the graph should be hanging. So the correct answer is 5th answer. Okay. Okay, so other ones you can do, no? You can do the 29th easy, 30th very easy. Okay, so you all are okay with this. Any doubts from this Pesuru book? Okay, so now we are going to finish the class with a different question. Okay, so that is from 2019, 40th question. Okay, so take that in your past paper book or whatever. That's a very interesting question. It's 40th means last 10, no, not one of the last 10. No, it starts from 41st. It is like almost last 10. Complicated. Okay, so-called complicated and difficult one. But let's try to solve it easily. It is an easy question. Okay, not all the questions from last 10 are difficult. So, okay, I'm going to draw it. Okay, inside. Okay. One is like this, the other one is like this. So this is car 1, this is car 2. So there are some letters. So this is some question that they should give to all levels. Very easy, but it is 40th one. It is also justifiable because our students complicate the easier ones. Okay. It cannot be easy. That is their mentality. It cannot be easy. So I have to complicate it. So don't do that. Just do the question. The 40th one. The figure shows the displacement time graphs for motions of two cars with respect to a lamp post. So respect to a lamp post. So always remember there should be a point from which the velocity is measured. Sorry, not velocity. Displacement is measured because the displacement is about position. So position relative to what? That point should be there. So it is here a lamp post. And they are continuing. Consider the displacement to the right side of the lamppost is positive. Right side of the lamppost positive, so left side is negative. A student has made the following statements regarding the motion of the graph, motion of the cars, relevant to the points P, Q, and R marked on the graph. Okay, so let's try to put it in a picture. Okay, to make it easier to explain. But if you do this in exam, don't do it. Okay, you'll be just wasting the time. I am doing this to explain you all, okay? Yeah. So this is the lamppost. Okay, so you can see the car 1 is starting from the negative side. So what does it mean, children? What does that mean? Which side the car 1 is with the lamp?
Left side.
Left side, right? Left side. Because right side is positive, so it should be in the left side. Car 1. So I put it C1. And I will draw like this because the cars move in opposite sides, no? Right and left side. So this is like looking from above. So the other car 2 is in the positive side, so it is in the right side. So it is car 2. And then if you just talk about the graph, so what can you see? The car 1, its displacement reduces with the time. So here the displacement is 0. So that means it comes to the lamp. Okay, it has reached the lamp. So car 1 is traveling like this and it reaches the lamp point. It reaches the lamp at P position. Okay, at this point. Position means, the point in the graph. Okay, and then it goes in this direction. So it becomes positive after that. It goes like this. It goes like this. Just showing it. Okay. What about car 2? It starts from the initial displacement positive. So it is in the right side. That thing we have put it correctly here. And here also the positive displacement is decreasing and it becomes 0 at R. So at R point, the displacement of this car becomes 0. It means that it comes to the lamp. Okay. It comes to the lamp. And then in the negative side, you can see the displacement increasing. So here it should travel like this, car 2. Okay, so this is how the motion is interpreted. So let's try to explain the statements. So first one, relevant to P, the car, regarding this P, okay, so relevant to P, car 1 coming from left crosses car 2. At P, it crosses car 2. Is it correct? So don't look at this, okay? These two are at the same point, but at different instances. You have to go for the graph. So when is during that P instance, at that P instance, the car P is at the lamp. What about, sorry, car 1 is at the lamp. What about car 2? At the same time, it is having a positive displacement. So it is somewhere on the right side. At the same time, the car 2 is having in the graph, according to the graph, a positive displacement. So it means that from the lamp, it is somewhere in the positive side. Okay, somewhere in the positive side. So it cannot cross. Car 1 coming from left crosses car 2. That is totally wrong. It cannot cross. Those two are in different position. If you want to cross, you have to like come at the same position, same displacement. But different displacement, they can't meet. Okay. I am at point America, another person is point India, they can't meet. Okay. Two different positions can't meet. So this is not possible. First statement is wrong. Second statement relevant to Q. Both cars moving towards the lamp post and cross each other. Regarding Q. So do they cross each other? Answer me that. Do they cross each other?
Yes.
Yes, they do. Why? Because they are having same displacement. So I mean they are at the same point. So it occurs in the positive side. So in the right side, when car is somewhere here, car 2 will also be somewhere here. And these people will be crossing them. They will be saying hi like that. So they are directly to, I mean they are crossing each other. Okay. So car 2 and car 1 are crossing each other at point Q. Does something strike you in the statement B?
Both are not towards the lamppost.
Very good, very good. The thing that they say, both cars moving towards the lamp. Do you think that when they move, I mean they are coming from opposite directions, both are moving towards the lamp? Is it possible in the world to cross and both of them to move in the towards also? Is it even possible? Even if you don't understand the Q, okay, even if you don't know anything about Q, can two things moving towards each other and also cross each other, is it possible? No. When they are crossing, they are crossing. When they are moving towards, there is gap between them. They can't cross. So those two things cannot happen. Okay. Moving towards the post, crossing. What the hell is that? That statement is actually not a good statement. Why? Because with that thing, without understanding anything, with that particular wrong part of the statement, people can easily find out the answer. Okay, so that is common sense. Both cars moving towards. It's not possible. One should be away and one should be towards. Or if it is this side, one should be towards and the other one is okay away. Because it's not possible to things moving towards and crossing. It's not possible. And C relevant to R, car 2 is coming from right, passes the lamppost. R passes the lamppost. It's 0, no? Displacement 0. So that is at the lamp. So from the right, it is at the lamp and left. So it means it's passing the lamp. So that is correct. So R is correct. The A is also correct. B is wrong. So A and C. Okay. But unfortunately, what happened was most of the students didn't read the towards part. Okay, in Tamil medium also, most of the students didn't read that properly. They just crossing each other. Okay, correct. I have seen many papers. People have marked P correct. So be careful. Okay, simple things you can miss. How do you avoid that? You do a lot of practice and you work hard, and luck is always in your side. Okay, the luck always go for the person who works hard. That is also there. Okay, in the world, that is the order. Okay, so that is how we finish this linear motion part, and I have homeworks for you. The first homework is in 2002 mechanics essay. You had to do mechanics essay, fifth essay, first essay, fifth question in part 2. So that is you have to do first one, second one, and third part. Okay, the other part is not needed. That is circular motion. And also you can do, if you want, 2012 essay also. Okay, those are the two direct questions. And there was one from 1997. You have past paper, you can do. Okay, so it will be like mixed with the force theory also. F is equal to mv. In 2012 essay is also mixed with that. This also mixed with that. But you have studied everything, so you just do. If you want, you can send to my email. I will correct. Okay, I will correct according to how in the marking scheme they would correct. So it's better to take practice. Okay, always do exams, do practice, do homeworks. So next class we will study the force part. Okay, so I will do a theory revision and the paper class like that. And after the completion of linear motion in this part, we can do one exam. Okay, model exam. So okay, that's all. Any questions? I will check the chat also. If you have any questions, you can ask directly to. Oh, one. So can you do 11th question? Yeah, I can do. Thank you for asking. 11th one. What's that question? Yeah, distances traveled by an object falling freely from rest during the first, second, and third seconds are in the ratio. So here distances travel in the first, second, and third seconds. So here the meaning itself is a little bit confusing. So what is meant by traveling in the first second? So let's say the fall starts when t is equal to 0. So then we measure the distance when t is equal to 1 second. So this is the distance traveled in the first second. And then we will be measuring the distance in the second 2 seconds. So this distance will be the distance traveled in the second. Not distance traveled by this time. They say by this time it is from beginning to this. In that particular second means the difference between the first end of first second and end of second. And the next part when t is equal to 3 seconds. So this is the distance traveled when we talk about the distance traveled in third second. Okay. So if you use s is equal to ut plus half at squared, ut is 0 if it is from rest. So half at squared if you use, at the end of this it will be at 5 meters. At the end of this it will be at 20 meters. At the end of it will be at 45 meters. So this difference is 5. This difference is 20 minus 5, 15. This difference is 25. So 1 is to 3 is to 5. So the answer is the fifth answer. You got it? Hope that you got it. So it is during. Okay, during. During means during that duration. So this is first second. This is second second. This is third second. During that. Okay. Any other questions? I will check the chat again. If there is any by any chance. Okay, good. Okay, so let's finish the class. Thank you very much.